Hi, this is a review for exam number 1. The exam will cover sections 1.3 to 2.4. In this review, we'll try to solve one problem from each section. However, you should understand all homework problems at least. Now, let's see the first problem. Sketch the graph of the function. If you want to sketch the graph, then first you may have to find the period and shift in the horizontal direction and amplitude and shift in the vertical direction. So you can sketch the figure step by step to reach at the final required graph. And however, you can do a little bit more easily solve the problem. Okay. And first we consider period. Okay. Now, once 2x, that portion is changed by 2 pi, then the function will make a whole cycle. That means 2x is start from 0 to 2 pi. So that let's say in this way, 2 pi, then it's making a whole cycle. That is the same as x is divided by 2. X is from 0 to pi. Then it is making whole cycle. So pi is period. Okay. Now, secondly, the range of the cosine function is -1 to 1, and also minus cosine also the same. Now, +1 makes the range of the given function here from 0 to 2. Okay. Now, and it is all the way oscillatory, so we can make the picture graph in this way. Okay. Now, here in x-axis, and that is now y-axis, and between 0 and 2, so that is 0 and that is 2. Okay, so this function will make some oscillation between 0 and 2. Now, we choose one specific point. For example, x equals 0. Then y will be minus cosine here 0 minus pi and +1. Cosine pi, cosine minus pi is -1, so that is 1 plus 1 equal 2. Okay, when x equals 0, it is passing the point, and we already know the period is pi, so that after pi is coming back again here, the value here. So here the midpoint, pi over 2, it is touching x-axis, and now coming up, and now it's going down again, and after pi again coming up, and down and up, and also the other side again, oscillatory way is continuous. So that here we have in the other side again down and up, and again down and up, and so on. So that position is now minus pi. Okay. Okay, that's the sketch of the graph. Now, for that problem, it is combined along with the sine and cosine. So we may have to unify sine and cosine by using some known formula. And sine square theta can be written by 1 minus cosine square theta, so that the given equation can be written as 1 minus cosine squared theta plus, okay, not plus, it's minus, okay, that is minus 7 over 2 cosine theta plus 1 equal 0. Okay, now we can rewrite. That is cosine squared theta plus 7 over 2 cosine theta minus 2 equals 0. And now this is a quadratic function of cosine theta. So to see it better, let's replace cosine theta by x. So it's change of variable. Then x must be between minus 1 and 1. Along with that change of variable, the equation can be written x squared plus 7 over 2 x minus 2 equals 0. So here now x-x separation, 4.5 separation. So it's a negation, this positive. So we can reach at x plus 4 and x minus half equal 0. Now x must be between minus 1 and 1 so that this portion cannot be 0. So that we have only the value x is half. But x half means that is cosine theta is half. Now to find the theta, and we may use a circle of radius 1. Cosine theta, cosine is horizontal component, so that here, and that's half, so that along with that half in x direction. Okay, that angle, the touch point here, angle, that angle, we have two angles to make cosine theta is half. Of course, this angle is now pi over 3, and this angle is minus pi over 3, and that is now minus pi over 3. But we have to find the angle between 0 and 2 pi, so that rather than minus pi over 3, we have to write down here 5 pi over 3. Okay, we are measuring the angle in this way. So that is 5 pi over 3. So we have two solutions, this and that. Okay, now number 2. What can you say about S of h is given in this way? So the given term is the same as e to the h minus e to the 0 divided by h minus 0, which is average slope of the graph, on the graph between 0 and h. If we are considering now, that is y equal e to the x, then that is 0, and we have h here. Then now that is average slope is slope of the secant line passing these 2 points. So you can say this is first of all the slope of the secant line. Okay, or the average slope, average change of rate between 0 and h for the function y equal e to the x. You can say that. Secondly, you may say in this way, as h goes to the 0, now here the quantity sh approaches 1, because here e is chosen among all here y equal a to the x and chosen such that the slope at 0 is 1. Now that is now slope 1. E is chosen in this way. Okay, so you can say now the average slope is approaching to the slope of the tangent line, but we know that the slope of the tangent line is 1, so that you can say as h goes to 0, sh approaches 1. Prove or disprove. By using change base formula, we can deal with this problem. The left hand side is same as natural logarithm x over natural logarithm of 2 plus natural logarithm x over natural logarithm 4. Okay, we rewrite it. So it's a natural logarithm x over natural logarithm 2 plus 4 is 2 squared. So 2 can go out by using a power rule. And so that's a natural logarithm x, the same numerator. And that's twice of natural logarithm of 2. Okay. So we have this quantity and half of that. So total is 3 over 2 and natural logarithm x divided by natural logarithm of 2. Okay, by using change of base formula again, you can write this one. Okay, 3 over 2 is constant, and then that can be written log base 2 x. So that is exactly same as right hand side. So that is true. We proved that. Now how about this one? Okay, cosine is has oscillation so that it has no inverse. However, once cosine is restricted, and here now 0 to pi, then the value is changing from 1 to -1, so the range will be here. Okay, let's say -1 to 1. Then in this restricted region, cosine is 1 to 1, and we can define arc cosine. So that is a cosine inverse or arc cosine. So this is how we define the arc cosine. Now, okay, here arc cosine, we cannot cancel cosine, arc cosine once it is outside of the domain. Once you are thinking arc cosine, then basically this cosine and arc cosine is now the range must be between 0 and pi for arc cosine. But right now this is a negative value, so that it's not working. Now to make it the correct, and we begin with in this way: cosine minus pi over 4 or cosine pi over 4 are the same value, so that now this is inside here 0 and pi, and also, and now so that you can, if you try to cancel, then eventually now you can get the value pi over 4. So if this one is replaced by pi over 4, then it is correct, rather than minus pi over 4. If the right hand side is pi over 4, then that is correct mathematical statement. Okay, so for given one, it is wrong. Okay. Now, the instantaneous slope of f at x can be estimated from here the average slope and taking h small, and we can do that. Now for given function fx equal x squared plus 2x, we want to estimate the instantaneous slope of f at x equals 0 and x equals 2. Okay, here we'll do only for this case, x equals 2. Then, now start with here the quotient as x equals 2 and h. That is same as now f2 plus h minus f of 2 divided by h. Okay, that is s plus h. That is now 2 plus h. That is 2 plus h squared plus 2 times now 2 plus h minus, okay. Now once x equals 2, that'll be 4, so that we have a 4 and one more 4, okay. Now divide by here h. Okay, we'll try to simplify it. Now that portion is same as 4 plus 4h and plus h squared, and now plus 4 plus 4h, right? 4 plus 2h. Okay, that must be 2h. And then minus 4, one more minus 4, and divide by h. So we have 2, 4, and 2 minus 4 cancel out. And now 4h, 2h makes 6h. And finally, remainder one is h squared. Divide by h. So it is the same as 6 plus h. So once we take h smaller and smaller, so approaching 0, then that is approaching 6. So at x equals 2, the instantaneous slope of f is now 6. For the other one, you can do it yourself. Okay, now fifth problem. Let's try to evaluate the limit. X approaches 2, then clearly the top and bottom simultaneously approaches to 0, so that 0 over 0 shape. Okay. Now that is the same as, okay, we can rationalize the expression. So same limit, and we multiply the conjugate. So there's a square root of x minus square root of 2, and here square root of x plus square root of 2. And the denominator is originally x minus 2, and we have to multiply square root of x plus square root of 2. And here the top becomes, okay, a minus b, a plus b, which is same as a squared minus b squared, which is now x minus 2. Divide by, now bottom we have x minus 2, and another part is square root of x plus square root of 2. So we can cancel this portion, and here x is approaching 2, so that we can easily see now that's a square root of 2 plus square root of 2, and top is 1, so that is 2 square root of 2. So that's the final answer. Okay, for this one, we assume the limit exists, and we try to find the limit. Now, as x approaches 1, the bottom, the denominator approaches 0, to have the limit, and also the numerator should approach 0. That means that x squared plus ax plus 1 should have now x minus 1 as a factor. Then because this is 1, now here only the choice is again another x minus 1, so that if it is expanded, then the constant part is now becomes 1. So here from this one you can easily see that a is minus 2. No matter what it is, it doesn't matter. Anyway, the numerator is given in this way. So the given expression is same as a limit. Okay, h approaches 1, and top is now x minus 1 squared divided by x minus 1. So 1 can be cancelled out. Sorry. That is now x minus 1. So x approaches 1. So the value is 0. That is the final answer. Okay, number 6 is the exactly same problem in section 2.3, exercise problem. fx is defined to be square root of 1 minus 5x, a is minus 3, and we chose epsilon 0.5. Then as x approaches a minus 3, the fx has a limit for, once you choose here minus 3, then square root of 16 is 4, which is L. Okay. For this given epsilon, we want to find the delta such that here fx minus L in modulus is bounded by epsilon 0.5 whenever x minus a absolute value is bounded by delta. We have to find the delta, and so that this inequality, x is chosen satisfying this inequality, then the function value is always here near around L, and distance is bounded by epsilon. Okay, so we start with that inequality. Okay, fx is now square root of 1 minus 5x, and L is 4, and bounded by epsilon is given 0.5. Okay, so we have to reach at some upper bound and lower bound of x. So we just peel out so that later on we'll try to get x standing alone. So here, first we eliminate absolute sign, then here minus 0.5, and here square root of 1 minus 5x minus 4 bounded by 0.5. They are same, and we are adding 4 both sides and every side. Then that will be now 3.5, and that is square root of 1 minus 5x, and this one is now 4.5. Now we make square, and there's 3 and 4 is 12 and 25, and that is 1 minus 5x, and 4 and 5, that's 20.25. Okay, so we reach at this one and subtract 1, so that's 11.25, and minus 5x, and that is 19.25, and divide by minus 5, then left hand side divide the minus 5, then minus 2.25, yeah, I guess it's right, and then that'll be changed. the direction is changed, and the limit part is x, and again this is changed, and if you divide it by -5, then it'll be minus and 3.85. Yes, yeah, we have that. Okay, so we have upper bound and lower bound of x. Okay, now let's try to visualize the interval. Okay, here that is minus 2.25, and this is minus 3.85, and now a is minus 3, so we try to get here a will be here around here, minus 3, and this distance is now 0.75. That distance is 0.85. So that here we have to choose. So we have to make this form of expression, and we have to find the delta. So that from here, now from that one, which will be minus 3.75. Okay, so we are considering only this one. Then that means that from x is chosen inside this interval, which means x to minus 3. The distance is, for example, now bounded by 0.75. Then that is subinterval of that one. Once x is chosen inside here, then it's the same as that, and backward eventually it will satisfy that inequality. So here now the delta is 0.75. Okay, that's the final answer. Okay, now let's try to solve the final problem, number 7. For A, okay, it is now we are trying to get one side limit as x approaches 0 from the right, and try to evaluate the e to the 1 over x. Okay, now pictorially, here we have 0 and x is approaching from the right, and okay, we consider first 1 over x. 1 over x. Then x is positive. However, it is approaching 0, so that basically this one is looks like here 0 positive, and it is reducing 0 to 0 from positive side, so that this whole quantity is always positive, and because the denominator is shrinking, so that the quantity becoming larger and larger, which means that this one is blowing up to become infinity. So 1 over x will become infinity, which means that the limit now, okay, x 0 plus and e to the 1 over x. This quantity, because 1 over x are becoming infinity, blowing up, so that whole value will become infinity. So here we write down here infinity. However, now there's no limit. Basically, infinity is not a number. It's a blowing up. Okay. Now, how about B? Okay. Similarly, we consider along with the graph, and this is 0, and now x is approaching from the left, and x approaches 0 minus, and that means approaches 0 from the left. So here again, we consider the part of expression. So that is basically, okay, this portion is always negative from the left-hand side was 0, which means the value is negative, so that now it is a form of 0 minus. Now this whole thing is negative, and also between magnitude, the bottom is becoming smaller, smaller, smaller. So the whole thing is becoming larger, larger, larger in magnitude, but negative way, so that it is blowing up to minus infinity. Okay, so here e to the 1 over x. This is now approaching to minus infinity, so that is just, we say e to the minus infinity, so that will be 0, so that here in right-hand side, from right side, the value is blowing up. From left-hand side, the value is now becoming 0. So once we try to make the picture, for example, now y equal here e to the 1 over x, then now the graph will be here around the 0. It's blowing up here. Now x is becoming larger, larger, larger. Then this quantity becomes smaller, smaller, smaller around the 0. So e to the 0 is around 1. So that now is above the line 1, but it is approaching 1. Okay. Now for the other side, and here it goes 0. But anyway, once it's negative, then this value never go up here 1. But once x goes to negative infinity and smaller, 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 then it is approaching 0, so that the value is almost 1. So that from here now increasing, so that it's approaching 1, like that. So the picture of the function can be made in this way. It's a little bit ugly, but anyway, this is the main idea how it behaves. Okay. Now we'll go to this problem. X approaches 0 plus. Okay, and now we try to find the limit. Okay, we'll use for this problem here limit x goes to 0 sine x over x, or limit x goes to 0 is reciprocal, that is x over sine x, that is 1. We'll use this fact. And here for that one, it's the same as, okay, now square root of x is there. Tangent x is same as sine x over cosine x. Right? And we have a bottom here, sine x. We can cancel sine x, and we can simplify in this way. Top is square root of x, bottom is now cosine x. So here the given problem is the same as limit x approaches 0 from the right, okay, plus, and square root of x over cosine x. Now top is approaching to 0, and now bottom approaches 1, so that eventually the limit must be 0. That's the final answer. Okay, this is the end of the review. Thank you.